Hi, I hope that the evaluating absolute value went well. We're going to start solving absolute value equations. So first we have to ask ourselves, okay, what is this equation asking us to do? Because it is a little bit different than a traditional solve. Uh, then can we develop a process? And we're going to talk more about this tomorrow in our groups. Can we develop a process to follow? Third, how is the principle encountered in the physical world? Meaning, where does this thing show up in real world events? So let's get started with that. Here's our first objective. What is this absolute value equation asking us to do? Well, the equation, absolute value x equals 2, is asking us to solve, for all values of the argument that are a distance of 2 units away from 0. So in these problems, what you're going to discover is that this is the distance you're traveling from your center, and then the centering number is whatever is based on what's inside here. Okay, so this one, there is no number with the x, so it's just centered at 0. Okay. Using a number line helps us, so we're going to mark 0 on our number line, and then we're going to count 2 units, because that would give us a distance of 2 units. We can go 2 units to the right, and we can go 2 units to the left, which means that our solution, x could equal -2, and x could equal 2. It's really an and. Okay. All right, remember we can go to the left and we can go to the right, okay? When you have absolute value, you're looking at distance, and distance is a non-negative number. So go ahead and give these a whirl. Come back and take a peek at them. I'll do them for you. So hit pause. All right, I'm going to go ahead and do them. This is the distance of 5, and our center is 0. So here's 0. Now I'm just going to go up by like 2.5, and I'm going to say this is 5 units, and this is -5 units, or 5 units to the left. Okay, so that means x can equal -5 and x can equal 5. Now if you counted by 1, your dots are going to be further out. I included C because I wanted you to get used to looking for this. We're never going to be able to have a negative on the right-hand side. Okay, distance is always needs to be a positive number. Now, when we go to split these out into 2 equations that we're going to do in a second, then we'll introduce that negative number. But as it stands with an absolute value, it cannot equal a negative number. So this is no solution. Okay. All right, so what happens if we don't have 0 as our centering number? What happens if we have an argument like x plus 2? Well, what it's asking us to do is find the values of x, then make the argument x plus 2 a distance of 4 units away from not 0, but -2. So why do you suppose it's -2? Well, there's lots of ways to think about it. The first way is if you substitute -2 in there, then it gives you a value of 0, and that means that it has to center on -2. The other way to think about it is if I put a -2 in, that's what it's going to take to cancel out that 2 and leave me with just an argument of x. So that's 2 ways to think about it. But in either case, I'm going to mark -2 on my number line, and then I have to count 4 units. 4 units. So that's going to take me to +2 when I go to the right, and it's going to take me 1, 2, 3, 4 to -6 if I go to the left. So that means x is equal to -6 and x is equal to 2. 2 answers because we can go in 2 directions, okay? Remember, distance can go to the left, distance can go to the right. Keep these answers in mind, because now we're going to approach a way. This is a graphical representation, and now we're going to look for an algebraic representation. So with an absolute value equation, we have to end up with two answers. So what that means is that if we're going to solve this algebraically, then we're going to need to come up with two separate equations that don't have absolute value bars to make an equivalent expression of one single absolute value equation. So what we do is we say without bars, x plus 2 could go off to the left. Without bars, that means it can go -4 units. So because we're talking about value instead of distance without the bars. Okay, so we're going to set up one equation that way. And then our right side without bars is going to look like x plus 2 equals +4. Now we just solve this and we get x is equal to -6. I just subtracted 2 from both sides. And then on this one, I got x was equal to +2. Compare those answers to what we got graphically on slide 4. Graphically, we got x is equal to -6 and x is equal to 2. The same thing, okay? So what do you notice? Oops, nope. All right, so go ahead and hit pause and complete these two examples, and I will work both of them out for you. Okay, so I'm assuming that you worked them, so I'm going to have x plus 5 could go off to the left, 4 units to the left, and x plus 5 could go off 4 units to the right. And I'm going to solve this by subtracting 5. So that means x is equal to -9. And then I'm going to check it. So the absolute value of negative, remember when we check, we always go back to the original, including the absolute value. All right, so that means the absolute value of -4 is must equal 4, and it in fact does. Sorry, I hit the wrong button there. Let me pop through here. So 4 equals 4, and that's a check. This is your check. This is a solution. Okay, I'm going to subtract 5 over here. And I get x is equal to -1. And then to check it, I would plug -1 in to my original absolute value expression, and I get absolute value 4 is equal to 4, and I would get 4 equals 4. Okay, and it checks. All right, but here's your solution. So let's try 2x plus 5 absolute value equals 9. So that means 2x plus 5 equals -9, and 2x plus 5 equals +9. Notice how I always make two equations. So now I get 2x is equal to -14, x is equal to -7, and you would check that. 2x is equal to 4, I subtracted 5, x is equal to 2, and you would subtract that. Now, what do you notice about these two equations and the ones that we did on the previous slide? Hopefully, what you notice is that the absolute value is isolated, and that's going to take us into our next type of problems. They're a little bit more complicated, but the thing that you have to remember is isolate, isolate, isolate that absolute value expression. Get it all by itself. So on these two, I'm just going to isolate first and then, but not solve, okay? So in order to isolate, I have to add this 4 to both sides. So I get absolute value 2x plus 3 is equal to 1. Now bust it into two equations. So 2x plus 3 equals -1, and 2x plus 3 equals +1. And you would solve from there, okay? Now on this one, in order to isolate, I need to divide through by this -3. So I'm going to divide both sides by -3 and watch what happens. I get x minus 4 absolute value is equal to -4. Can we have an absolute value equal to a negative number? No, no solution. You try these two on your own and then come back and look at the answers. I'm going to go ahead and start working. Hit pause if you to try them on your own. I'm going to isolate first. And I'm going to get 6x plus 3 is equal to 1. Those are an absolute value, so that means 6x plus 3 equals -1, and 6x plus 3 equals 1. And I'm going to solve. So 6x equals -4, x equals -4 sixths. So equivalent x equals -2/3. Here I get 6x is equal to -2, x is equal to -2/6, x is equal to -1/3. Okay, and you could check both of those answers. Now with this one, I'm only going to get it to the part where you can bust it out into two equations. I'm going to divide through by -1. And then watch, now I have absolute value x minus 4 is equal to 2. Now I can bust. X minus 4 equals -2, x minus 4 equals +2, and then I can solve from there. Okay? The last objective is to work on a physical world is to work on how this appears in the physical world. So the Spaulding Corporation manufactures tennis rackets. This is something that manufacturers deal with all the time. To meet industry standards, an adult racket head must be 100 square inches plus or minus 20 square inches. So this is a tolerance type of problem. And when you do this, anytime you see within a range or plus or minus, think absolute value, okay? So they want us to write and solve an equation to determine the range of possible head sizes that meet the standards. So you're always going to have an actual measurement, you're going to have a target measurement, and then you're going to have some tolerance. And the absolute value of the actual minus the target has to equal the tolerance. So in this case, our actual, that's what we're looking for. That's the things that we're testing, so that's our X. Then our target is the 100, the industry standard, the 100 square inches. And our tolerance is 20 square inches. All right, so here we go. We're going to plug this in, and we're going to have the absolute value of x minus 100 has to equal 20. And like with every absolute value equation, we have to bust this into two. And we would have x minus 100 equals -20. X minus 100 equals +20. And we're going to solve. So x is equal to 80 and x is equal to 120. So this is your smallest area, and this is your largest area for the racket head. Okay? All right, now I'd like you to take that questionnaire. It's a Google form, so I've listed it there for you. So go ahead and take that questionnaire, and it'll give me some feedback about what we need to discuss in class tomorrow. And I want you to think about one more thing. Is there a situation where your absolute value would only be required to be busted into one single non-absolute value equation? And we're going to talk about that tomorrow. So thanks for listening. See you tomorrow.